And what we're gonna do is we're gonna do a quick review of what we went over yesterday, just in case anybody missed it. I had already posted it. And then we'll go ahead with today's lesson. It shouldn't be too long. If hopefully we have a little bit of time at the end, then I'll go back and answer any questions that anybody else has. Again, tomorrow, if you look at the calendar, which was one of the things I went over yesterday, all I have set up is a practice day. If everybody can see my screen, right? So all I had is a practice day. That's if you haven't been told, like our classroom is a computer lab. So our classroom is a computer lab, so we're going to be using a computer a lot. And every time you see these practice days, it's just going to be class time to work on your weekly assignment. I have not monitored really yet who's joined Khan Academy, so if I have a chance to do it tomorrow, even though I'm out, I'll try to check up on that and harass you guys via remind to join if you haven't joined yet. But you'll find out if you haven't joined when you get the F for the week if you don't do the assignment. So I went over all that stuff yesterday. Quick recap of the e-class page. You have the Zoom link that you would click each day. Again, tomorrow you don't have to do that because tomorrow I won't be here. If you haven't looked at the syllabus yet, that's up here also. So is the syllabus receipt form. As of right now, I have Lana hasn't done that, Jordan hasn't done that, Katie, Maylee. Those are the only ones this period that haven't done that syllabus receipt form. I also need you guys to join my Remind. If you haven't done so, here's the code for Remind. This is the way I communicate, mainly, especially now in this type of distance learning type of thing. And then probably the most important thing on the e-class page is over here, the content area. We're on week 1 today. If you're not sure what week we're in, you can look at the dates. Here are the videos. I told you I would post yesterday's video, and I did. If you click on week 1 lesson videos for some reason you missed, or even if you just want to see it again, this is all the stuff we went over yesterday. I posted it. You also have the notes, which hopefully you either print it or put in a notebook. I do notes by the week, so these are the week 1 notes. Week 1 is really just 1 day long because yesterday we didn't do math, and tomorrow is just a practice day. So really the week 1 notes are just what we're going to go over today. And then finally you have the homework assignment, which I'm not going to go over step by step again how to join Khan Academy. That's on yesterday's video. A lot of you did. The last I checked there was 9, and I think this period has 19 people, so that would tell me that if my math skills are correct, that 10 of you still have to join Khan Academy. So make sure that gets done. The first assignment is due on Sunday. Any questions on anything I've said so far? Okay. Whoa, that's not sounding good. Is that you, Ferris? No, man. No, man. The notes are for you to keep. I don't grade notes. The notes are just for you. If and when we get back in school, those notes I print them out and I give them to you, and then I put the little hole punches in and everything for you, so you can keep them in your notebook. But obviously that's not possible right now. So you got to take care of the notes on your own for right now. Correct. And this week you don't have Delta Math. This week is just Khan Academy. So no problemo. Any other questions? Okay. All right. So now this is going to be a little bit of a science experiment. Let's see how this works. I need to switch over to the smartboard, and then I have you guys on a separate screen, so I'll still be able to see you if you speak. All right. Screen sharing. Did that thing turn off? Alright, just give me a minute. This is the first time I'm testing this out, so I gotta see how this works. Um, Anybody else show up late? Katie, you need to join my remind and fill out the contact sheet, the syllabus. You haven't done that, Katie. Anybody else? Who's K? Who put K? Like you wanted to put your name on when you sign in, because that's how I take attendance. I want to be able to read your name. Oh, never mind. That was just Caden. Okay. Katie, did you hear what I said? Okay, or not. Alright, so we do that. I'm gonna see if I can take off. Nope. Take that off and move this one. Nope, don't want that. Nope. Yes. So we can move that one over here. Alright. And then now you should be able to see me. You can't see me for real? Oh, lies. Alright. Wait, I think I might know why. Let's see if this will work. Ferris, quit being so popular. Alright, I think that'll work better. Again, sorry for the technical difficulties. Can you guys see the... Because that's the thing, I need to start sharing the screen. Yeah, but you can't see it like it doesn't look it shouldn't be look. Yeah, that's the problem. That's what I need to do. Sorry, this is the first time. It should get better. On it. Oh, good. All right, that's what I wanted. Now let's try to do. All right, now can you guys see me as if I'm screen sharing? All right. Again, sorry, this is the first time I'm doing this, so it's, no, there it is. Perfect. All right. Sweet. So now you should be able to see me. Right? You guys don't have. If you guys turn on your video so I can like, you guys see the faces and I get more up onto the board. All right, so the first, like this first unit is going to deal with circles. Specifically, we're going to deal with angles and segments in a circle. So today is just still kind of an introductory day. It's not getting too specific. It's kind of vocabulary. First one that we're learning is what a chord is. Okay, a chord is a segment. It is entirely inside of a circle. It does not go on the outside. You guys have all taken first semester geometry, so you know what an endpoint is. A chord has endpoints on a circle. Can you tell me of any other segment that you already know of in geometry that has endpoints on a circle? Just shout it out if you know it. Very, no, diameter, yeah, that diameter. So what we're gonna say is that a diameter is a type of chord. Every diameter is a chord, but not every chord is a diameter. So if I wanted like to draw another chord that was a diameter, what are you building? So the only thing extra that a diameter has that a chord doesn't is that it passes through the center. What are you building? Benjamin. Oh, man. Okay, any questions on chords? A secant is going to be very similar to a chord, meaning that it touches the circle twice. The only difference with a secant is that it extends beyond the circle. It doesn't have endpoints. It's going to go through the circle. It's not just on the inside, it's also on the outside. But because it touches the circle twice, it's going to have a lot of similar properties as chords do. A lot of the things that we can do with chords, we can do with secants because it touches the circle twice. Now something different is called a tangent. Okay, a tangent is almost entirely on the outside of the circle, but that it touches the circle at one point. And can anybody use context clues to try to figure out what the name of that one point is that a tangent touches a circle? I'm staring at you guys. It's almost like we're in class. So I'm looking at you guys. See, Jordan still has his video on. It looks like he's in the dark. A tangent touches a circle once at one point. Does anybody want to take a guess of what that point is? Jason, I can see you. I can see you. Diana, I can see you. Miranda. No. What is the name of the point where the tangent touches a circle? I'm screen sharing so everybody can see what I'm showing you. It is not always called point C, though. You're not going to always call it point C. But what do you always call where a tangent touches a circle? On the screen. There you go. I missed having a comparison on. Good. The point of tangency. A tangent touches a circle at the point of tangency. We're going to look into that. You're going to hear that word more than once. Any questions so far? Anything on the first page? so we move on. We do a little bit of practice here. We're gonna give names to segments, and that's something that we learned to do in the first semester of geometry. We know how to name segments, we know how to name lines and radius and all that other good stuff. So here, let's start off with the diameter. What is the name of the diameter of this first circle? Or it's segment A. Yeah. And since diameters have endpoints, they are considered to be segments. What type of segment is a diameter considered to be? What we just learned? Somebody not make Ferris tell me? Type of chord, sure. But because all chords are segments, we give it the segment symbol. Is that the only way that you can name the diameter? Is there any other name I could give that diameter? I wish I could see Diana and Miranda and Manny and Jordan and Lana and Jason. Hey, do you know another way to name that diameter? You guys can just unmute, like unless you're in a room where somebody's playing the music in the back, which I actually did here yesterday. I thought that was funny. If you're in a quiet room, you can just leave the mic unmuted. That's fine. Is there another way I can name that diameter if I wanted to? Remember, I get through this. No, no, like a name. Like, is there another name other than that that I can give it? You could also call it how about the radius? What's the name of a radius here? Okay. Okay, he said VC. VC is fine. Segment VC would be one. I don't have enough too much space here, but you could also call that CB. Are there any other radii in the diagram? AC will work. Yeah, remember the definition of a radius is a segment that has endpoints. One endpoint is on the circle, one endpoint is in the center. And is there any other radii that you see that are visible? Wait, one at a time. CV, correct. Yep. Rolling along. How about chords? We talked about a chord. There's one chord that's already on the board right now. Okay, well, KL is the one that's not on the board yet, so you are correct. KL is a chord that's going up here as endpoint on the circle. But what else is a type of chord? Yeah, that same diameter. Every diameter is going to be a type of chord. How about a tangent line? Remember, the tangent line is the line that touches the circle exactly once. Say that again. Uh, yeah, it's remember where the line, the symbol is maybe still shy, Lana's still shy. Hey, Miranda. Demon. Demon made an appearance. All right. Demon was in it. Point of tangency. I told you that was going to come up again today. What is the point of tangency here? Yeah, where the point is. Alright, we made it to the first diagram. I thought we were going to make it seem like in a minute, but let's try to speed this up a little bit. Example 2, identify each of the following segments as a tangent, a chord, a radius, a diameter, or a secant. Sweet. Alright, so HG, and I'm going to help you out. I'll highlight this for you. HG. What type of segment is this? It is not a tangent because a tangent would only touch a circle once. This will cross the circle twice. Yeah, it's a secant, and so you might be confused saying, oh, but Mr. Romero, hold on. You said that a secant has to be a line. Well, typically secants and tangents are usually lines where they have the arrows, but they don't have to be. The main thing about a secant is that it exists, that it contains points both inside and outside the circle, and that it also touches the circle twice. And even though they didn't highlight it, if they didn't give that point a name, if it's touching the circle there, and it's touching that point here, that's what makes that a secant. Okay, how about YE? What is YE? It is a chord, but even more specific, because typically on these things, they're going to tell you be as specific as possible. But you want to be more specific, because it's also passing through the center. What else is it? Yeah, the diameter. But remember, again, diameters are also types of chords. But if you only have to give it one name, if it was one of these where, which best completes, what's the best way to name it, it would be a diameter. Diameter is more specific. Wherever you want the diameter is important. How about FD? What is FD? Right there. Yeah, just a chord, nice. Rolling along. How about a CE? What is CE? Radius. Fantastic. Radio. And then finally HA. On the outside of the circle, it touches the circle once. Tangent. Okay. Any questions there? All right, a few more definitions. I'm not going to read every single thing here. I'm just going to kind of give you the gist of each one of these, and then you can go back and read it on your own later. But this first one says that if in a circle, if they were to tell you, I mean, in this case, they tell you here in writing, but you should already know how to mark diagrams. If they were to tell you that two chords are congruent, their minor arcs are congruent. Now, you're not going to really know what an arc is this week. One day, we're not there's not a lot of time to elaborate. This is more week two. We're going to get into arcs, but this is an arc. And an arc has this type of symbol. I don't know if you saw that in the first semester of geometry, like a little dome on top. But it's telling you that if the chord is congruent, the arcs are congruent. If it's a conditional state. If. Any questions there? All right. The next one, okay, is if you have a diameter or a radius, this also works for a radius. See how it says also radius, something that's touching the center. But if it touches a chord at 90 degrees, if it's perpendicular to a chord, then it bisects that chord. What does the word bisect mean? Take your answer quicker and move on. Leave it unmuted. Cut it in half, sure. And this is a very common diagram. So if you look like this, these two are the same. If I were to tell you, hey, TU is 7 units, what else do we now know? If you were to see a diagram like this and then they tell you, hey, this is 7 units long, what else do we know? That, there you go, look at that, Muhammad and Sarah. The UV is also 7 units long. Very common diagram. Now this last one, I know it doesn't show up in your notes. I kind of caught it later that there wasn't a diagram, but you can go ahead and just draw this in something like this. If this last property tells you that if you draw a perpendicular line to two different chords, and those two perpendicular lines are congruent, if those two little lines are congruent, meaning if they're equidistant, you see equidistant, then the chords themselves, okay, then chord AB would be congruent to chord BC. That's also a very common diagram. So you might want to what I would draw on your paper if I were you. I would draw what you see already. Draw this with the little 90 degrees being important. Draw that they're congruent. And if you know that, then you also know that the chords are the same length. Because they meet at 90 degrees, what else do you know? Let's see who's paying attention. Because they meet at 90 degrees, what did you learn in the last property? Because of this 90 degree, what else do you know? Miranda, I haven't heard from you yet. Hi, what's that? Miranda, what did you learn in the last property? Anybody? Sammy Boy, welcome. Let's see, Kimon, Jason, Atlanta. All right, so if you were here, can you hear me or not? Okay, all right. Okay. So we learned in the last property that because of that 90 degree, also bisect. Yeah. You didn't hear anything on this last one? Yeah, yeah. What I was trying to explain is that I know that I know that this did not show up in the most, at least the diagram did. The wording is there. But if you can just draw this in, what you see here are two chords, and if you see two chords, and you see the center of the circle, and then a segment going to each chord, moving at 90 degrees. You learned in the last property that because of the 90 degrees, it's going to cut the chords in half. But what this one tells you is that if those little smaller segments are also congruent, if they're the same as each other, then the chords themselves are also congruent to each other. So you can say that segment or chord AB is congruent to chord BC. Does that make sense? Hear me there? All right. What do you see over here? Just without reading anything, what do you see here quickly? Tell me if you can describe that in your own words. You see a tangent? Yeah, that's the first thing I see right off the top. Tangent. What else do we see? A radius. Good. And then more importantly, what's happening with that tangent and that radius? Not only are they intersecting, they are, they're perpendicular and they're meeting at that word that we said, that phrase that we said we were going to hear a lot. Yeah, I know, but that's just, what did we call that point? What did we call that? What did we call that? At the point of tangent. So the types of problems that you see a lot here are they're going to draw a radius, they're going to draw a tangent, they're going to make them meet at the point of tangency, and then they're going to do this. What does that mean? If I draw one more segment like that, what does that mean? Well, from you learned in the first semester, what does that make when you draw that? What type of triangle? A right triangle. Good. Good. And what's that property, that theorem that we learned about the sides of a right triangle? Pythagorean theorem. Get ready to use that a lot. Here's another thing you're going to see a lot. What do we see drawn here? Cone? No, oh, I guess it does look like a cone, but we haven't gone over three-dimensional solids yet. So, here. What do we call these? Segments outside of a circle that are each touching the circle once. No, not chords. Chords are inside. It starts with a tan and ends with a jet. Tangents. If you have two tangents that meet at the same exterior point, then automatically those tangents have to be congruent. I'm sorry? Now, the only thing is that each tangent, in order to be a tangent, can only touch the circle one time. And each of those segments only touch the circle once. So if they meet at the same outside, if I were to draw, I'm not very good at drawing, but these are my favorite chords. But if I were like to draw, a tangent this way and like that, and as long as they meet at that same outside point, they have to be congruent. They have to be equal. Okay? So a couple quick examples. I tried my best to get the same type of stuff that's on the homework. Just full transparency. Khan Academy, especially if you've been in my class before, you know that. So like I'll assign a module and I'll give you like 4 problems and like 3 of them are perfect, but there's one that's a little bit out there. So and that's what I saw. Like I can't control the individual problems. So there might be one problem in there that has a little bit of stuff that we're gonna cover next week. Remember that Khan Academy has their own videos also. So you can try looking at those and see if it'll help. It's not the hardest thing ever. And I'm also available through Remind if you need help on something like I only gave you one module this week, so it shouldn't be too difficult. What do you see here on the on this first example that I told you were going to see? This first example here, what do you see? What do you see on the first example? Yeah, the triangle, and it looks like you have a tangent and a radius, and a lot of times they will tell you that you have a tangent and a radius, but when they tell you, then they're going to be asking you for one of these missing sides. But in this case, none of the sides are missing. They're giving you all the sides, so they're asking you when it's tangent. In order to be tangent, we have to check if this is 90 degrees, and in order to check if it's 90 degrees, we're going to use Pythagorean theorem. So hash brown CBT, remember Pythagorean theorem is a squared plus b squared is half equals c squared. We're just going to test it out. In order for this to be tangent, then 11 squared plus 43 squared is equal to 45 squared. I know this is 121, but I'm going to have to use my calculator for the other ones.
Daddy?
Squared. This is plus 1849, 45 squared is 2025. In order for this to be true, if you add the other two, 121 plus 1849 is 1970 equal to 2025. Are those two equal? Are those two equal? No. Thank you. Funny, last spring, one of the common things that you hear from the kids, oh, but we don't learn well from videos. We don't learn well. We need that interaction with the teacher. So I'm trying to provide that now. So, same thing for this next one. Again, a very common thing is like they'll like let's say they'll take that out, okay? Then like they won't show you that, and then they'll say, okay, they're gonna instead of asking you if it's tangent, they're gonna tell you it's tangent. They're gonna tell you find AC. Well, then you should know how to use Pythagorean theorem. Okay, so this is kind of the same thing, but they're just asking. Like now we're testing to see if it's 90 degrees. In order for it to be 90 degrees, then 7 squared plus 24 squared. What do you call those? On a right triangle, what do you call the two sides that meet at 90 degrees? You were clueless. No, the hypotenuse is the other one. What do you call the other two? It starts with L and ends with X. Very good, the legs. let's test to see if this is true. I know this is 49, obviously. I know this is 625. Oh man, is it 576? That is 576. That's there. So we do find out that indeed 625 is equal to 625. So let's answer the question. Is BC tangent to the circle? Yes. Yeah. Is this my Sammy board? Okay. Is see the video from yesterday? Okay. All right, last example for today. Last example for the week. Again, tomorrow I am out. Tomorrow we look at the calendar. It's only a practice day. You do not have to come on Zoom tomorrow. You just work on your homework. If you haven't done it already, great. So you have to come do tomorrow. If you haven't, that's what we're scheduled for tomorrow. But what do we see here on this last example? Okay, let's be more specific. We do see that. We see two lines. Okay, we see tangents. That's good. I like that word. I like the word tangent. And not only are they intersecting, but how else can we describe that? Yeah. Well, okay. Maybe I phrased that poorly. What I wanted you to say is that they're intersecting at a common exterior point, which is what we saw on this slide here. And what did I tell you happens if two tangents um, intersect at a common exterior point? What happens? Yeah, that's what so now you're gonna. It's not that it's a bad property, but you're gonna probably hate this because right, if they're congruent, that means that they're equal. This is gonna be a throwback to algebra 1. When you make them equal to each other, what type of equation does that become? I need for algebra, you should know this, but a while ago. What do you call it when you have an equal sign on one of these guys? It starts with Q and ends with R. This is quadratic. Yeah, it's a quadratic equation, so we want to move all the terms to one side. 11 minus 11, and we get x squared minus 9 equals 0. From this point, well, remember, what are the two most common methods for solving a quadratic equation? What are the two most, one of them should be obvious, even though that's the one that we're not going to use. But there's one in the name. What's one of the most common ways for solving quadratic equations? X factors that make it, that's like a TV show. Quadratic formula is one of them, but that's the one that we're not going to use here. The one is factoring. Okay? So it's up to you how you want to solve this. Okay, but I would factor here because that's what we know as a difference of squares. Difference of squares, they have a difference between the factor in the middle and we have two separate squares. Times itself is the x squared. So we have to multiply times itself to get x squared. X. X times x is x squared. And if you remember the difference of squares in algebra 1, a difference of squares, you remember this word, conjugates. Remember, I would say it's like, conjugate is, and x times x is x squared, you put the x's there. What times itself gives you 9? Split and solve. Plus 3 equals 0. And then we use -3. We have two solutions. -3, and +3. Um, all they wanted you to do is solve for x. So you always want to check that, because sometimes you'll have to end up getting this and plugging it back in for x. But all they were asking you to do is solve for x. That's kind of the gist of what we're going to have this week for homework. The thing is, this week, really, this week and next week are supposed to all be together, but since this was a short week, and with all this computer stuff, like, it's hard to fit everything into this week, so I did my best to split it up into 2 weeks. This should be enough to carry you through most of the homework. Are there any questions? Yes, so I see a hand up. Who's that? Angel, what's up, man? Hey, over here? Yeah, this one here, okay. I did, I did it wrong. I added this one. It's a check. We're not solving it. We're not solving correctly. We're just checking. Yeah. I just want to see if those numbers fit into Pythagorean theorem. Now watch, since we have time and since you asked, here, let's make our own pretend problem. Let's say they were to tell you, they were to say, hey, this is tangent. They're not asking you, they're telling you that this is tangent, and they wanted you to find AC. Okay, well now you would just use Pythagorean theorem and say 11 squared plus 43 squared equals to x squared. Okay, this would be the same 121, this would be the same, oh man, I forgot. This would be the same 22, 18, same 1849. You add those two, 121 plus 1849, is that same 1970 that you were asking me about. But now you would take the square root on both sides, and the square root of 1970 is about 44.4 roughly. More or less like 44.4. So the if they were to ask you, hey, what would AC have to be in order for that to be 90 degrees? It would have to be around 44.4. The reason why this failed the test before is because it wasn't 44.4, it was 45. Anybody else have any questions out there? It's hard to see you guys, so instead of raising your hand, you can just unmute and say something. Do you have any other questions? All right, so what I'd like to do today, instead of just dismissing all of you, I know some of you came in late. I want to dismiss you one by one to see if I need anything from you, because then I need to yell at you. And I still have about 6 minutes to yell at you. So let's try to do that. Sit down, sit down, sit down, sit down, sit down. It's working. Okay, I know, Poppy, but yeah. Okay, let's do that. Let's stop sharing the screen. Now I see you guys again, and let's go to my attendance. All right, so Ferris was here. Ferris, you're going to take care of that remind thing? Did Ferris leave already, even though I told him not to? No, okay. Okay, good, perfect. Yannick never made it today? All right, Lana, you're going to take care of the remind and the syllabus sheet? Okay. Hey, all right. Tomorrow and next week we'll work on the camera thing. Let me see. Daisy never made it today? No, Daisy. Turn this off.